So, remember we are currently focused on finding out something about the endocrine glands, and then we did spend some time on finding out about the thyroid and the hormones of the thyroid, and we learned that the thyroid has one of the most important functions it performs is the metabolic function, and without the involvement of the thyroid, perhaps the rate of metabolism will almost fall to 50% what it normally should be. It is so important. We will now move on to yet another equally interesting gland, endocrine gland, which we call as the adrenal cortex. What do you call it as? It's a very interesting gland. Just focus on this. It has such a profound impact on a large number of things. The adrenal cortex. So let's try to find out about what this adrenal cortex is, and it is located, as the name indicates, it is located just above the. I'm sure you have seen this when you did the rat. So what are we looking at? You can see the pair of kidneys there, and just sitting on like a cap. There are two kidneys sitting like a cap on the kidneys. You have what you call as the adrenal glands. It is covered with rich fat tissue is there, and in that you have the two adrenal glands. Each gland is about very small, about 4 grams. 4 grams, what is 4 grams? Okay, it's very small, but it has a very profound effect, as we shall soon find out. So, to find out what gland is like histological, just find out. So, I take a section as usual, take a section through the adrenal gland, and then I find that it is made up of, so this is the section through that, and at the center I immediately identify the medulla. What is it? It is large neurons, and I know that it is a source for hormone. What hormones? Adrenal medulla is a source for what hormones? Epinephrine and norepinephrine. Okay, and these are what hormones? These are derived from the tyrosine derived hormones. Remember, we had categories, 3 categories. There was some of the hormones which belong to tyrosine derived, others were peptides, and still others were what? Very good, very good. What were they? Steroid hormones. Okay. So, what we are talking about is, whereas the adrenal medulla here right in the center, this greyish patch, it indicates neurons. What are they? Neurons. What are they? Neurons. And they synthesize and release what hormone? Tyrosine derived hormone, namely what and what? Epinephrine and norepinephrine, and they go directly into the blood, and then we have seen that they do the function of we have already seen that. Okay. The adrenal cortex is very different. The adrenal cortex is very different in the sense that it secretes the hormones which belong to the steroid category. It is a very complex gland. The inside is medulla, which is epinephrine and norepinephrine, and outside is what? Cortex, which is consisting of cells which secrete hormones, more than one hormones. And in terms of chemistry, what are they? They are steroids, hormones, and structurally the adrenal cortex is divided into 3 layers, 1, 2 and 3. Let us ignore the inner one, medulla. So, outer one is called as zona glomerulosa. What do you call it as? Zona glomerulosa. We will talk more about it. Glomerulosa, fasciculata and reticulata. These are the 3 zones, the outer zone, the middle zone and inner zone. I am not talking about the medulla, I am just talking about the cortex. It is divided into 3 layers, 1 layer, 2nd layer and 3rd layer. If you go deep into the core, you will get medulla. I am not going to talk about it. Okay. So, zona glomerulosa, zona fasciculata and zona reticularis, we will by we will acquaint ourselves with these names and their respective functions, and this is histological. Again, just take the section, put through the microscope, and you find the outermost thin layer, extremely thin layer of cells, which is called as zona glomerulosa. Zona fasciculata, the cells are arranged more or less strands of cells, series of cells, 1 cell, 2 cells, and there are strands of cells, and they are radially arranged. Means what? From like the spokes on the wheel of a bicycle, they are arranged. So, and then the innermost part is zona reticularis, and if I go down there somewhere, I will get medulla, but which I am not going to talk about. And then this is a very interesting gland, because if you normalize it per gram, you see the highest amount of blood that is flowing anywhere is in the adrenal cortex. Huge amount of blood, okay, very highly vascularized adrenal cortex, and also medulla is one of the most highly, okay. Now, listen to this. The steroidal hormones. Why steroidal chemistry? It's a steroid. Chemistry steroid. The steroidal hormones, depending on the type of function they perform, Okay, we classify them. So, like biology, everywhere we first classify, and then when we, by the time we have understood the classification, we go for the exceptions. You will find that is what happens in biology all the time. It is irritating sometimes, but it is true. Okay. We have to deal with it. Okay. So, first I will tell you some of the rules, okay, which try to govern the functions of the adrenal cortex. Okay. What are they? Some of the steroid hormones, they perform the function of releasing glucose from the liver. What did I say? Releasing glucose from the liver, and this function is called as glucocorticoid function, and those hormones, those steroid hormones which do it are called as glucocorticoids. What did I say? Glucocorticoids. What is a glucocorticoid? It is one of the steroid hormones. What does it do? It has a profound function in the regulation of carbohydrate. What does it do with reference to liver? It brings about the release of glucose from the liver. Glucocorticoid. Okay, got it? One hormone. The second category of hormones which is released by the adrenal cortex are called as mineralocorticoids. What do you call them as? And as you guessed correctly, I am sure you have guessed that it has a profound function, profound role in the regulation of sodium and potassium in the blood and in the everywhere in the body. Sodium, potassium. Okay. Therefore, mineralocorticoid. Are you okay so far? The third category of hormones which is released by the adrenal cortex, the third category is called as androgens. Amazing, androgens, male sex hormone. Now, this is interesting. Do you mean to say that adrenal cortex in a woman or in a female is also releasing a male sex hormone? The answer is yes. The answer is what? Yes. In the males, testis is a prominent organ for male sex hormones, which is testosterone, which is very strong, very powerful hormone. These hormones which are released by the adrenal cortex, male sex hormones, they are not that strongly active. The testosterone activity is minimal, but it is there. Okay. So, you can just imagine, and under normal conditions it doesn't matter much, but in a case of female, if there is a tumor in those cells which secrete male steroid hormones, okay, she could have excess of androgens, okay, which could have consequences. So what is it? Does it mean that? So, please remember one basic fact. Do the males have testosterone? Yes. Do they have the female hormones? Of course, yes. Okay. Do the females have female hormones like estrogen and progesterone? Yes. Do they have testosterone? Of course, yes. Okay. So, all the genders have all the hormones, it is only just a question of proportion. It is just a question of what? Proportion, it is just the question. Okay. Now, that having been said, now I will draw to your attention to the zona glomerulosa. So, again we are looking at the adrenal cortex. Here author has drawn for us the medulla cells, the large cells, and here the three layers, zona glomerulosa, fasciculata, reticularis. The outermost layer is known to secrete a mineralocorticoid hormone, fortunately very familiar with it, and the name of the hormone is, what is it? Aldosterone. So, fill in the blank. Aldosterone is secreted by cells. Which gland? Cortex. In the adrenal cortex, which layer? Zona glomerulosa. Is very clear? Zona glomerulosa. Okay. The second layer, which we call as zona fasciculata, the second layer, which has all those strand-like cells, okay, it secretes a large number of glucocorticoids. Again, I will step back. This secretes aldosterone, and aldosterone happens to be, okay, aldosterone, step back again. Aldosterone is secreted by what? Zona glomerulosa. Aldosterone is the most important mineralocorticoid in our body. Why did I say the 3 times? It's very important. Why? Because, so tell me the name of the most important mineralocorticoid in your body, and where is it secreted from? Zona glomerulosa. Excellent. So far clear? Remember? Okay. You can't, this has to be remembered. Okay. The most important glucocorticoid in a human, I am using the word human, okay, because there are variations across mammals, but I focus on humans. The most important glucocorticoid in humans is called as, again, cortisol, and it comes from which layer of the adrenal cortex? Zona fasciculata. Now, zona fasciculata secretes many hormones, okay, different glucocorticoids, but I am going to talk about the most important, that is cortisol. Okay. And then the inner layer, which is called as zona reticularis, okay, is the layer which secretes a lot of androgen like hormones, okay, the male sex steroids, whether you are a male or female, okay. The zona reticularis will secrete several male steroid hormones. One of them is DHEA, dehydroepiandrosterone. Okay. Now, you know something, if you take simply adrenal cortex of rat, okay, and make an extract and then do whatever chromatography is available there, okay, you will find that it contains about 30-40 different kinds of steroids. How many? I do not know, maybe 30, 40, 50, whatever, different steroids. Are all those steroids hormones? No. No, they are not hormones. Several of them are intermediary metabolites or intermediary steroids. Means what? Means what is a steroid? Is it being released by the adrenal gland? No. Does it go into circulation? No. Does it have any receptor? No. Then what does it do? Well, it is there. It is then soon converted into another steroid, into another steroid, and into another steroid, then that steroid is a hormone. So, the number of actual hormones that are being released by the adrenal cortex is not more than 5-6. And out of those 5-6, we are only going to focus on 2, make your life very simple. We are going to focus on what? 2. And what are the 2 hormones I am going to focus on? I told you just now, one is what? Aldosterone, which we have already done, and the second I am going to talk about is what? Cortisol. But that should not give you, you should not go home with a wrong impression that that is the end of it. No. There are other steroid hormones. For example, there is another steroid hormone called as corticosteroid. What did I say? Corticosteroid. Say that again. Corticosteroid. Whereas in humans and in mice, cortisol is very important glucocorticoid, cortisol. But in rat, it is the corticosteroid and not cortisol. Well, both the hormones are there, whether you are a human or a rat or a mouse, both the hormones are there. Okay? But for we humans and mice, which is the most important glucocorticoid? Cortisol. But if you are a rat, then which is the most important glucocorticoid for you? Corticosteroid. Okay, have I given you a broad idea as to the world in which we have to navigate now? Okay. All right. Now, the story begins with, our adrenal cortex can synthesize right from very small molecules. We can synthesize cholesterol, but that is a very minor part. Most important part is we eat a lot of cholesterol. That cholesterol is taken along with the lymphatic system. Okay, absorbed lymphatic system. Finally, those molecules, they find their way into the liver. Okay, and the liver keeps on secreting what you call as low density lipoproteins. What is it? It is a huge mixture of several proteins and several fats, huge complex, several molecules put together into compartments. Where is it? It is there in the blood. Now, please remember it is abbreviated as LDL. What does LDL stand for? Yeah, and homeostatically it is important as to how much LDL you have and what kind of fats are there. Okay, if they mess around, then it is an indication that you have problem with the deposition of certain fats in your coronaries. Okay, but I am not going to talk about it. So, these are coming from the liver, and these are taken by so they are in the blood, and as they flow along, in the cells of the adrenal cortex, there are receptors, there are protein molecules which can selectively absorb the LDL. Means what? In these cells, of the adrenal cortex. In the plasma membrane, there are protein systems which we will call as receptors, which will selectively pick up LDL from the blood, take it inside, and from there they will take cholesterol, and that now cholesterol is the source for all the steroid hormones. So, what have we done? We have tried to understand as to what is the molecule, the parent molecule, okay, which has to be there in all steroid hormone synthesizing cells. What is the parent molecule? Cholesterol. Say that again, cholesterol. So, whether actually we are talking about the adrenal cortex or other steroid hormone secreting glands like testis in the case of male and ovaries in the case of female, what is the parent molecule? Start with cholesterol. And where does it come from? Liver, in the form of what? LDL. Okay, and it is taken in by, okay. And now, so this is a, so there are 4 rings, 6 membered, how many membered? 5 membered. And this is called as a steroid nucleus. What do you call it as? Steroid nucleus. And the steroid nucleus, to identify as to the position of every carbon, we label it as number 1, number 2, number 3, number 4, 5, 6, 7, 8, 9, and the cholesterol has about how many? So, in a cholesterol molecule, how many carbon atoms are there? Say that loudly. 27. Now, please remember, for as a student of at least nodding acquaintance in the chemistry, some of the positions are very important. I will particularly ask you to remember number 3 position. Okay? A little change here and there, you remove H and put double bond O, and some other steroid happens, and then you do, and then some other, and then its property change. Okay, and then it becomes other steroids, etc., etc. So, please remember position 3, remember position 18, remember position 20, just 3-4 positions. It will make your life simple. Okay. Now, we begin with at the level of cholesterol. Is cholesterol a hormone? No, cholesterol is not a hormone. No, out of question. Cholesterol is not a hormone. So, we begin with the level of cholesterol. It is taken in the cell, and in the cell we have in the cells of the cortex. In the cortex, each layer will have different sets of its own enzymes, and what the cells will do is, first thing that it does is it cleaves the, okay. So, there are 4 rings there. Are you okay? And then I will call them as the side chain. Okay, that side chain is cut, and it is cut away by an enzyme which is called as the phenomena is called as side chain cleavage. Cleavage is cutting away, side chain cleavage, and if you cut away the side chain cleavage, how many carbon atoms were there originally there? Say that again. When you cut away, about 21 carbon atoms remain there, and then you play with that steroid molecule, and so you have the cholesterol, and it gives rise to this molecule in which you have the OH group here and C double bond here, CH3 there, and this about C21, and this molecule we will call as what? Pregnenolone. What do you call it as? Say that again. You have to remember this. Pregnenolone. What do you call it as? Pregnenolone. Now, in all steroid hormone secreting cells, by that again, what do I mean? Cortex, and then ovaries and testes. This is going to happen. Here you begin with cholesterol. Okay, you remove the side chain cleavage, and then you will have pregnenolone, and then pregnenolone molecule is then processed into the adrenal cortex into this adrenal cortex to give rise to one steroid hormone, which we call as what? Aldosterone. Why aldosterone? Let us look into the logic. It is very simple. At the 18th position, I will draw your attention to what is there? CHO. Hello. Do you see CHO there at the 18th position? Therefore, it makes sense to call it as what? Aldehyde? Aldosterone. Therefore, aldosterone. Okay. Are you okay there? I will tell you why it is aldosterone. This is aldehyde, and this double bond over here, aldosterone, ketone. Are you with me? The basic logic which is there, always there in the chemistry. Okay, labeling of a molecule, that logic is very much applied here, and there you have aldosterone, and then here you have the cortisol. That cortisol indicates OH group here, OL cortisol here, and then of course there are testosterone, estradiol. We will talk about when we talk about the gonads.